In today's video, we will be taking a look at Postgres, sequence, and serial data types. See you after the music, eh? So hey guys, I really appreciate you hopping over here. If you're new here, Teach Me Database is all about providing you free, in-depth, as much in detail knowledge of database possible. So if you're new, consider subscribing to the channel. And hey, if you like the value of the contents I provide or the videos solve a problem for you, give us a like, give us a subscribe. All right. Before I get into the detail, I'm gonna do a little bit of self-promotion. Okay. So Teach Me Database website is all about providing you all the contents I upload here on YouTube, and of course I have planned to have all the contents available for free. But if you want access to all the code, all the homework, the problems, the solutions, then I will ask you to subscribe. You can just go to Teach Me Database, pretty much just click subscribe, and it's pretty easy to subscribe to our newsletter as well as our email. All the videos and everything is available. The code bases and tips and tricks, especially for our subscribed user, is only hidden. It's hidden till you subscribe. All right, enough of the self-promotion. So what we're gonna do today? So today we're gonna be taking a look at a really cool concept in PostgreSQL called sequence. You would have used sequences if you have ever created a table with a primary key which is set to auto increment, like using a serial, and you set it like unique. Let me show you what I'm talking about. So you do something like, you might have done something like create table if not exist foo. That's like the simplest name possible, and then you set like ID is primary key and unique. Okay, and you provide a serial data type. Okay, so if you have done this, congratulations, you have already used sequence. Postgres use sequence construct to create this serial data type. I will get into the detail right now, don't get confused. If you have not used it, don't worry about it. We'll just let's just start with the sequence. So what is sequence? What does it help us with? So sequence is a construct in PostgreSQL which provides you an auto increment or decrement provision with respect to whenever you are using it. So if you go into the C code, let me hop into the C code of Postgres over here. Don't get intimidated. Don't worry about if you don't understand it. But if you take a look at the C code, you can see like the whole file, the sequence table data. These all are like defined sequence. They are mainly objects. Okay. So at the end of it, it's nothing fancy. It's just that Postgres converts the code into C, and then in C they are pretty much their sequences are objects which have, of course, some hidden private functionality inside the object which you can't access, but it also provides hooks and other functions to use to manipulate or utilize that objects for your purposes. Enough of the source code for now. Let's get back to our editor. All right. Over here we have sequence definition. So let's start with sequence definition. So in my understanding, sequence is an object which provides you, sequence is a construct in PostgreSQL which provides you ability to have auto increments or auto decrement and produce sequences as your table grows with data. So creating a sequence is pretty simple, although it looks kind of like, it looks a bit cryptic. It's not, don't worry about it. So over here we have create temporary temp sequence. The simplest way to create is create sequence let's say foo. Why am I choosing foo all the time? Let's choose something else. I don't know. Maybe you tell me. SEQ. All right. That's it. Let's see. Does it work? SEQ already exists. Okay. So if you want to check if this SEQ exists, Postgres provides in the schema information tables, there is a table called PG sequences. And over here you can see what are the values in PG sequences. So don't worry about the first two. Over here you can see we have public sequence. This sequence which you created is available in PG sequences, and for any permitted sequences generated, you can check all the sequences available in your schema if you have the permission by doing select all from PG sequence. So don't worry too much about it right now. But sequence has a name, okay, SEQ, which we provided. Sequence owner is Saurav, which is me. Then data type is big int. We have not provided the data type. Where does this come from? Okay, let's take a look into this. Create temporary temp sequence. Temporary mainly means it's gonna provide, it's gonna build the table for the session. That's it. If not exist, name. That's the first line. Okay, I like that. I don't want to have it temporary, but let's check what happens if we do it temporary. Okay, yeah, does it show up in PG sequences or not? So I'm gonna just copy and be like really bad programmer and do like SEQ1. So now I've added it here. Sorry, drop sequence SEQ. Let me drop it first. I want to add like this temporary attribute sequence. Create temporary sequence 1. Okay, there we go. Let me remove this and let's take a look at this. So you can see the schema name is a bit different. The schema name here is PG temp 3 because this is temporary for the session, for the user session. SEQ1, and we have Saurav, and the whole everything remains the same with respect to what you had previously. Right. Let me do one thing. I'm gonna okay, let me stop this session and let's see what happens. Oops, why can't I? Okay, there we go. Now I stop the session and let's try again. Okay, there we go. So I tried again. I stopped the session. As I said, for temporary case, it is only available for your available for the scope of your session. So over here, when I stopped my session and restarted the session, you can see the last sequence 1 which I created is not here. So temporary mainly creates it for the scope of your session. Okay, let's move further. I think we are clear about the first thing, right? So let's improve our query which we wrote in the top line. And before that, by the way, you can always drop the sequence with drop sequence if exist. It's always good to check if exist. I mean, it's not gonna be like a big issue, but if you're writing a function to do all of that, your function might throw an error. So it's always good to have if exist check. Drop sequence if exist SEQ. I'm gonna drop it. And now, from what we learned so far, for the first line, let's not add a temporary temp, but let us add if not exist before the name. Okay. Now I created this sequence. Let us check in the PG sequences. There we go. Voila. We have the sequence present. Awesome. Okay. You can see the last value is null. Let me make it bigger. Cache size is 1. Cycle is none. Increment by is 1. Max value is this weird big number. Then we have min value, start value, big int, and so on. Okay. Where does this big int, start value, min value, where does this all come from, and this max value? Let's explore this now. So let's go to the second line. It says as data type. Now what the hell is data type here? So let's go here. What it says about data type is the optional clause as data type describes or specifies the data type of the sequence. Valid types are small int, integer, big int. Big int is the default. The data type determines the default minimum and maximum value of the sequence. That means this big int which you are seeing right here came from default. Okay, and we also going to be taking a look into the source code, so it would be even more clear how it actually works. Okay, the start value, min value, and the max value. This max value came from big int. Now you might be wondering, what is this value? I don't really understand. Okay, so in that case, let's take a look at numeric types. I'm also going to put this link in the description below. So over here in numeric type, you can see like there is a big int number which has storage size of 8 bytes, which is a large range integer, and its range is this. Do you see this number over here? Let's check. It's right here. See that? Oops. 92 blah 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 and so on. Okay, this is it. So what it means is, based on the data type you chose, small int, integer, big int, the range of the increment is gonna be chosen unless you have provided a value. We have provided arguments and not relying on, and you don't rely on the default value. So I want to add that value. Okay, I want to try it out. I want to see what happens if I choose something else. So if as they're saying as data type, let me actually do this. Okay, as I want small int. Okay, firstly I'm gonna drop it again, and then I'm gonna create it again, and now let's put this all the way at the top, right over here. Yeah, I like that. So now let's take a look into it. There we go. So now we have sequence, we have Saurav, small int, and now check at the range value. Max value is 32767. So the whole point is, if the increment starts from 1 and it reaches 32768, it's gonna throw an error unless you have set it to cyclic. So this is how you can utilize data type, and that's gonna help you set default value with respect to your data type. Now you might ask, hey, why would I ever choose small int or int if big int is already available, right? Well, big int is 8 bytes, which is a lot of storage compared to 2 bytes. So if you don't really need that, why would more memory will always mean less performance unless you improve the performance. You find a way to improve it. If you don't have to really use big storage, big memory, then don't use it. You know what I'm saying? So in that case, just use a small int and then save memory, and your query might be faster, your operations might be faster. Let's go ahead. Now we have a sequence. I can also, of course, try to do an int over here. By the way, I'm just dropping and recreating this table, so that's pretty much what I'm doing. So now you have integer, and you can see like the value is now the max value allowed for a 4 bytes a space, which is 214748364. So when you convert into that, that's the maximum value, maximum bits a 4 byte storage space can provide. So that's why. Anyway, let's keep moving. Then we have increment by. Okay, so then you can provide like how much you want the increment to be. I'm gonna put like let's just do small int. Okay, and then I'm gonna put like an increment, which is the third line, and I want the increment to be, I don't know, like 2. Okay, cool. Let's first drop this sequence again and then create this, and now let's take a look at PG sequences. Now the increment by is 2, so when you use that, and I will tell you how to, increment, how to do increments, unless you are using a sequence as a serial data type, which I'll also explain how PostgreSQL converts it. But for now, you can see like the increment is set here, which is 2. So if I by auto increment, this is gonna increment by 2. Let's keep moving. Then we have min value, no min value, max value, no max value. No min, no max value pretty much means null. Okay, so you can provide min value. I'm gonna do the same thing again, drop, and then let's add one more line here. I want the min value to be 10. Okay, let's see what happens over here. What is the definition? So now we have sequence. The start value is 10, min value is 10, the max value is 32767, coming from a small int range. Okay, and increment is 2. Awesome. So min value, can I set a max value as well? Sure, why not? Let me do this on the same line. Whoops. Max value is, I don't know, like 100 maybe. Let's say you never have to go above 100, or maybe your use case is that you always want to allot 1 to 100 number to different rows. Okay, and then you want to reset it. You can use cycle, and we can explore it just like in 2 seconds. But here, let's see if I do this, what happens, what is the definition in PG sequences now. So public sequence small int 10 10, increment by 2, and the min value and the max value is 100. You see that? So now what happens is, if the increment, either you can also provide the value as well, to for that particular column. But if the increment is more than 100 for auto increment, it's gonna throw an error. Okay, then we have start with, then cache. So start pretty much means this start value, so by default where it's gonna start. I hope it makes sense. So you can just provide like start. Let me do like start, I want to start by 5, and then you have owned by. We might or might not use owned by, but let's see what it says. Oh, sorry, I forgot cache. Okay, so cache, what does cache do? Let's see what are they saying. The optional cache specify how many sequence number are to be pre-allotted and stored in memory for faster access. The minimum value is 1. Only one value can be generated at a time. That is no cache, and this is also the default. So the cache option mainly pre-stores or pre-allots sequence, like a few sequence, let's say 1 to 10, and allots it into the memory, so that in the future, when you are adding, when you are creating more, you are inserting more values, then those are fetched directly from memory and not generated. This is kind of optimization step. You could do it, you might not do it, don't worry about it. Then let's keep moving. Finally, we have no cycle. Well, I want cycle. Let's see what happens if I do cycle. Okay, so now I have cycle, and I think, yeah, that's pretty much, we don't have to provide like true or false. Whoops. And let me drop this sequence, and let me create this sequence. Okay, start value 5 cannot be less than min value. Oops. Okay, that's a good thing. So the min value was 10, the start value was 5, which is kind of an error. So in that case, we can set it to 15. Let's try, but that's good. I'm glad we made this error, because now we understand that there are errors happening. So now let's take a look at this, and we can see like we have the max value is 100, increment by 2, and the cycle is set to true, and last value comes from operation. So you have to call next val function for last value. So don't worry about it. Let's not jump ahead. So you can see like the cycle now is set to true, and so if your value increases by 100, then it won't throw an error. It will reset itself to start value. Okay. So now you know how to create this sequence. Okay, pretty cool. And I will suggest you should play around with that. I'll drop this link in the description as well. Try it out, see how it goes, create different kind of sequences and so on. So owned by is one final option which we have not used, which mainly says owned by option causes the sequence to be associated with a specific table column, so that if the column is dropped, the sequence will be automatically dropped. So it's kind of like cascading. So if you want, you can attach a sequence with a table by associating it with a column. If you do want to use cascade so that one table is dropped, then you want all the sequences to be dropped, that might be an option. Okay. Alter sequence, mainly what it does is you can have the sequence over here. So I'm just gonna so create, we already did over here. Okay, now let's do an alter sequence. So what they say about alter sequences, so it's mainly used to alter it's nothing so different from alter table command. So it's mainly used for altering the sequence itself. So that means if you have a sequence already created and you want to alter the definition of the sequence, you can utilize alter table. So let's take a look right here. Alter sequence if exist name as data type. You can change the data type. You can change the increment, min value, start, restart, cache, alter sequence name, and everything. So it's not too complex, but just for the sake of showing you guys, I can just do this. Okay, alter sequence if exist. It's always good to use if exist in your queries. It is error safe. Okay, and I do sequence, and what I want to do is I'm just gonna copy. Okay, let's try removing the cycle. So we can do like no cycle over here. Okay, let's go over here, and you can see like the cycle field has been set to false. Okay, pretty simple. It's just altering the definition you have already said, nothing fancy, just like alter table if you have used it. Finally, we have drop sequence, where we can remove sequence just like drop sequence if exist, and this also supports cascade. So if anything, any view, any any other table depends on this, those table will be dropped as well. Okay, sequence can be dropped. Cascade automatically drops object that depends on the sequence, and in turn all objects that depend on those objects. Okay, so we can just use it like drop sequence seq, and then we can do cascade, and it's gonna drop everything related, all objects related to that. So let's do this. Finally we remove this value. All right, pretty simple. Just to recap, we saw how to create a sequence, what are the different options, arguments, how to alter the sequence, what are the different options, is pretty much the same. Okay, you can use the same option, you just have to do alter. Okay, and then we saw drop, which provides cascading options as well, and you can also do like restricted if any object drops on it. And by the way, this is the default as they're saying. Okay, so now we know the definition and how to work with it, where it gets stored, PG sequences, what schema information table gets updated when you create a sequence, where you can check all the sequence for any schema. But now we're going to be taking a look at the source code. So I'm going to put this link in the description so you can have a better understanding if you want to explore. But I'm gonna walk you through it. It's a bit complex, but we just have to worry about the main logic. Okay, so over here all they do is pretty much like this is a more of a prototypal definition. I won't say prototypal definition, but more of a higher level definition. We have used if not exist. This is the place where they check if not exist parameter is provided, then it mainly logs an error, and then it just returns, it will just fail safely. So although this function, this high level function is the main interface, one of the main interface when you create a sequence. The main function we need to take a look at is init params, which firstly takes all the params and makes sure it creates a hash of all the params, so that C code can go through it and can invoke or create an object properly. So the init param, you can see like over here. So I'm just gonna search for it. Let's go here. So you can see after the checks and everything, this main defined sequence is mainly calling init params, and it is passing all the different option it already has by default, as well as the options you have provided, the argument you have provided. Let's keep moving. Let's find init param again. These are all okay right there. So init param, what it does, it takes all your like a list of all your options you have provided, and you can see like it tries to gather start value, restart value, increment by, and each of the options we explored, like increment, min value, max value, start, cycle, cache, all of these are right here. Okay, so you can see like for each, it's going to each of the options, each of the arguments you have provided, and now it's checking, hey, if it is as, which is this as, then what it is gonna do is it's gonna mainly set the as type attribute, as type, which is right here, diff element, which is pretty much a node. It sets the as type, which comes from here. So you have a small int, so small int is passed from def l, and it is set into as type. Similarly, increment, we provided increment, it comes here, it also does like some error checking, okay, and then it sets the value over here. So you can see this is how it processes. It's just a for loop which processes all your argument, and then it creates the whole object. If you want, you can go explore more, but this is kind of how it operates, how it acknowledges your arguments, and how it builds the object, which has the functionality, which provides the hooks which you can utilize for your operations. Having taken a look at the source code, now let's keep moving. So we explored, so far we explored create, alter, drop. We also explored source code, so this is also done. So we already took a look into the PG sequences a little bit and how it stores the value. Let's take a look into the source code as well a little bit with respect to PG sequence. So we already saw like this defined sequence is the higher order component, which mainly triggers all the functionality. So if we go scroll down over here, after setting all the values with init sequence, which we explored previously, this guy goes into setting the values, or actually adding all those values into the PG sequences table. So you can see the values are being extracted from here and then being put into PG sequence table inside one row. And here this is like mainly they are creating a lock on the table and setting it, and then closing the table and so on. Don't worry about it. But mainly the point is this: when you initialize, when you create a sequence, at that time itself, they add that whole, like the whole data which you are seeing over here in PG sequences. They add it after extracting all the value. So the process is like it parses, it extracts all the argument, it sets it, it makes sure there's no erroneous issues, and at the end of it, if all are set and done properly, then at the end, that's why this is at the end, they will add all that information over here as you are seeing to the Postgres PG sequence table. Okay. Now let's take a look at serial data type. So in the start of the video, I already told you about serial data type, how you use serial data type in creation of table. So let's say you create a table with this serial data type. By the way, if you want, we can also open up the documentation for Postgres data type. Let's take a look at serial types over here. The data types serial and big serial are not true, but these are not true types, but merely a notational convenience for setting up unique identifier columns similar to auto increment property supported. And the current implementation specifying is equivalent to create sequence this, create table this. Okay, so what they are pretty much saying is the serial data type utilizes creation of sequence, just like we did over here. All right, the same thing. This also creates if you choose to have a serial data type in your table, that means it's gonna create a sequence and it's gonna log that sequence into our PG sequences table. Let's take a look into it with an example. Okay, so let's say I want to create a table. What should be the table name? Ocean, because ocean is in front of me. All right. Ocean. Okay, cool. I want the ID to be serial, to be unique. Okay, and I want the name to be let's say text. Okay, let me add a comma, and also to be safe we should always do if not exists. Okay, so over here you can see like the table ocean was created. Now let's take a look into, or let's take a gander into our PG sequences. Okay, can we find something which was created over here? Let's see. Look at this. There's another new sequence created. By the way, we didn't create it. Who created it? Remember, this source code created it. Okay, it created a new row into the PG sequence, and the serial attribute, when you set it, the whole execution flow is, it first of all will create a sequence, then it will add the sequence argument. It will probably be default or the argument you have provided in table column, and then it would be adding that to PG sequences. So you can see over here it added ocean underscore ID underscore sequence. So the format was table name, then column name, and then underscore SEQ. Okay, by default it was integer. We could have provided a different value here, and that would have translated over here as well. So for integer we have already taken a look at the range, and that says the highest value would be, the maximum value would be this. Okay, pretty cool. So this is what really happens behind the scene when you use a serial attribute. So drop table if exists, whoops, and we have ocean. Okay, now let's create it. Good. So now we have this was created, and again in the background what happened, firstly a new sequence was created over here, ocean ID sequence, and the integer, the data type and everything was chosen. Now keep in mind, when I dropped the ocean table, there was a cascade happening, because this ocean ID sequence was dependent on the ID column and the table was dropped. So cascadingly this sequence was also dropped. Okay, so if you remember, this owned by, this particular field is actually the one responsible for setting up owned by ID by default when you use a serial on the sequence. So the owned by is ID, and so if the table is dropped, well, your sequence will be dropped. So if we drop table over here and we try to take a look into PG sequences, you can see that sequence was dropped. Okay, I hope this has been clear so far. So far, again recapping, by the way, if you want to take a break, take a break. Let's come back afterwards, pause the video, take a 10-minute break, come back, we're gonna continue again. Okay. Now we have already taken a look at create, alter, drop. We have taken a look at PG sequences. We took a look at serial data type, how adding serial data type in your table definition creates a sequence in PG sequences. You can take a look at that, and how a dropping of the table also drops that particular sequence from PG sequences table as well. Next thing I want to discuss about is mainly serial functions. The first function I would like you to be introduced to would be next val. Okay, so we'll do select next val, and as you can see, let me try it again, and as you can see it says provide a sequence, and there is like red class. Select next val. Okay, then we provide a sequence. Well, what would be the sequence? Let's say SEQ. Okay, sequence. Okay, next val is 15. This is interesting. The start value we provided was also 15. Okay, next, try it again. Select next val. 17. Why did it become 17? Take a look at this. Increment is 2. So you are smart. You would have figured it out already that next val has something to do with increasing the sequence value. And you are right. So apart from exploring the next val on sequence, which we define, we can also run this on the ocean ID sequence which we generated. Let's take a look into next val ocean ID sequence. Okay, so over here I'm gonna wrap it inside single quote. Okay, there we go. So the next val is 1. Again, if I do this again, it will be 2, and it will increment. Why? Because here we have not provided any argument for the sequence generated. The sequence name is ocean ID sequence, so it is going to use a default value, and we can check the default value over here. You can see this is an integer, start value, min value, and so on. So to explore how it really works, how this function work, and also to understand how Postgres really stores sequences, we're gonna be doing an interesting thing. So we're gonna be exploring what is actually stored inside SEQ or ocean IDs, SEQ, and so on. So it's pretty simple to do that, and I should have covered it in the start, but it's fine. We can do it here. So select all from, we can do SEQ. That's it. Let's see what is this stored at. So this is pretty much one row, a table with one row. The last value is 19. The log count is 30. You don't have to worry about. And is called is set to true. Is called is evaluated when the next val is evaluated. Okay, or set to true when next val is first invoked. So now if we do a next val again, let's take a look at the state of this sequence. You can see the last val is set to 21. So the next val mainly goes and update this table. Okay, and it sets the last value, increments it, and you can utilize it. Now let's go one step further and take a look into the source code to see how it really evaluates that. Okay, so I'm gonna go back to over here where I have sequence.c file open. I'm gonna try to find next val. Okay, there we go. So there's this next val internal, which is, I think, is the main, which is the main function which corresponds to you invoking next val on your ID or on your Postgres server. So let's take a look into it and see what really happens. The main logic you can check right here is that the element.last is updated, is incremented by the increment value itself. This is the most important. If you don't understand anything, just take a look at this. Element last plus equal element increment. So the last value, which is right here, see that last value has been incremented by the increment value, which in this case our increment value was, I think, 2. So that's what this code pretty much does. Okay, simple, very easy. It's just an increment, taking the value from the table, like sequence table, and then just incrementing it. Okay, moving on. The next function I would like to take a look into would be current value. So what does current value really does? This is cur val, and then you can provide it the sequence name. Let's see what it does. It is 23. Interesting. What was the sequence value right now? 23. Okay, let's do it again. Let's see if it increments something. Nope, 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 nope. So that was kind of stupid, but the whole point of that, doing it again and again, was to show that next val, although next val increments the value, because of the definition you just saw in the source code, like it increments the value over here. Current val doesn't increment the value. Current val mainly returns the value from the sequence itself when next val has been evaluated. Okay. For current val, you have to provide the name of the sequence itself. Okay. So yeah, result is element lost. That's pretty much it. Okay. And what is the element? Element is the sequence table. And what was the sequence table? We saw that, people, remember, select all from sequence. This is the sequence table. It's a 1-row table which has last value, log count, and is called. Okay. So what it does, it mainly it opens up the sequence table. Here there's like some error catching, and then like this whole code is, I would say, like this is error catching, but at the end of it, it's the return value of the result is mainly the element last, which is last value in the table. So that's why cur val returns the last value. Okay. Now another function I want you to understand would be this, and I feel this is more of a convenience function, which is last val. Okay. Last val does kind of the same thing which cur val does. The only thing is it doesn't take an argument. So let's go over here again. So over here you can see cur val takes in PG function argument, it takes in a sequence table, and so on, right? But over here you can see in last val there is no such sequence table which is gathered from the input itself. What last val does is kind of the same, but it mainly takes a look at the next val evaluation and what was the value set by it on whichever column, on whichever sequence we call the next val on. So then it returns whatever has been the last use sequence. I mean, if we evaluated it on next val on ocean ID sequence, then the last value will return us the last value from the sequence ocean ID SEQ. But if we have run next val on SEQ, then the last val will evaluate on SEQ. So the last val mainly, I'm trying to say, is evaluates the last value which was set by next val irrespective of the table. So it doesn't allow you to provide a table. So if you want to provide a table, it's gonna throw an error, as you can see. It mainly, for that particular session, it mainly goes and takes a look into what was your last invoked next val and what table it operated on, whichever was updated last, and then it goes and operates on that and fetches the last value from that table. Okay. So we already took a look into the source code as well, and I'm gonna add this source code, the whole source code, so you guys can also take a look into it. If you want to find what particular sequence was generated for a particular column in a table, what you can do is you can go into select. This is pretty much a function provided by Postgres schema information tables, or I should say schema information function. This is, and then this takes in a table parameter, which is, let's say, ocean. Oops. And then the column itself, which is the ID. Okay. And what it will do is it will return the schema name as well as the name of the sequence generated associated with that particular column. So let's say you have a table and you saw there are columns, which has serial data type, and you want to find associated sequence. This is another way to find it. This PG get serial sequence. Okay, you provide the table name, you provide the column name, and it will find the sequence name for you. So I hope you gathered enough value from this video. I tried my best to cover as much in-depth knowledge about sequences and serial data types as possible, but let's recap. So firstly, we took a look into what is sequence really, how is it stored in PG sequences table, and at the end of it realized, oh, it's just a table. We then took a look into create, alter, and drop constructs, as well as went into the source code and found out how it all works in C language, because Postgres at the end it's just C structures and objects. Then we found out a little bit more about serial data type, and we realized, oh, serial data type just creates a new sequence, which is again altering PG sequences table. Afterwards, we took a look into few functions like next val, curve val, last val. I left one function, set val, because I feel it's kind of different from what sequence definition is providing, because increment is already there. If you want to alter, well, do an alter, but you can also take a look into it. In the description you would have the link. Then we took a look into PG get serial sequence, which helps us gather the sequence name associated with the column on a table where you are using serial data type. And finally, we also explored the source code related to all these functions. Now, if you want to make the most out of this video, I want it to be interactive. So I will show you a homework which I want you guys to do, and maybe afterwards in comments you can let me know how you approach that problem. That homework solution would be available if you subscribe to teachmedatabase. So if you go to teachmedatabase, you can pretty much subscribe, and then you will have access to all the code and the homework assignment solution. Now let's take a look into this homework itself. So what I want you to do is I want you to create a sequence called auction logs, which starts from say 100 and has an increment of 50. Use this sequence to log the action activity on a hypothetical laptop being auctioned on eBay. So every activity which happens whenever somebody is doing an auction and increment is happening, but an increment is, let's say, 50, then you have to add a new row into auction activity using the sequence you created. Afterwards, next task is you should go and alter the sequence to increment it not by 50 but by 60. Afterwards, when you are done, you should drop this table, drop this sequence, and then go into PG sequences table, query it, and make sure that it is actually dropped. Okay, this is your homework. Work on it, and it's gonna be helpful for you, because practice is the best way to learn programming. I really appreciate you guys hopping over. It's really beautiful outside. The sun is setting, so I'm gonna head out. I hope this video provided you enough value. If you liked it, give us a like, subscribe, and also don't forget to sign up for our newsletter and full access on teachmedatabase.com. I appreciate you over here. Thank you.